Let's take a look at this problem involving a plane flying in the wind. So this is a common thing to do in trigonometry. It's a favorite trigonometry problem. The plane is doing one thing, the wind is pushing it. And so what the plane is actually doing relative to the ground is different than what the plane thinks it's doing. So the plane has a heading and an airspeed. Airspeed is how long that vector is. And the heading is 75 degrees east of north. So we don't measure things in standard position where we measure north of east. We measure from north. So our heading is 75 degrees east of north and 100 mile per hour airspeed. That's what the plane thinks it's doing. But the wind is coming along at 165 degrees east of north at 40 miles per hour. So the wind is going to be moving the plane. And so the plane will have a different ground speed and a different track. So track is what the plane is actually doing. Ground speed is how fast the plane is going relative to the ground. And track is labeled in, as being measured east of north. Now, the key bit of information here is that the heading of the plane is 75 degrees and the wind is 165 degrees. The reason that this is convenient for us and why we do this problem here early on in our trig careers is that that makes a right angle between what the plane thinks it's doing and what the wind is doing to the plane. Once we put a right angle in, that's what we're looking for in any problem that I give you right now about solving triangles. If there's a triangle somewhere, it's probably a right triangle. And then a right angle shows up with a 75 degrees heading and a 165 degree wind. That's going to put a 90-degree angle between the wind and the plane. So if I change that angle of 165 to like 155, all of a sudden it's a 100-degree angle, and we don't know how to do that yet. We don't know how to do that one until chapter 7. It's crazy. We learned this one in chapter 4 or chapter 1. I move this angle just a little bit this way, and all of a sudden it's a chapter 7 problem. Crazy. That's fine. That's fine. But this fits the category of problem that I told you to look out for. Find your right triangle. All right. So once we have this right triangle, I'm just going to grab this right triangle, put it down here the way we normally orient triangles. Now, the ground speed we could find just with the Pythagorean theorem because I got a 200 and the 440. So the ground speed is the hypotenuse. So it's just going to be the square root of 200 squared plus 40 squared. So the square root of 200 squared plus 40 squared. So 203.96. And I forgot where we were rounding it. By unit? Oh, ground speed, round to the nearest unit. So we want to round the 203. So it's 203.9. I'm just writing digits down because I'm doing this to round. 3 is where I want to round, so I'm going to write this as 204 miles per hour. We're deciding between 203 and 204. Since it's 203.9, we're closer to 204. That's the nearest unit. The other thing that we need to find is the angle. Now, the angle in the triangle is not the one that we're looking for. So notice that the angle in the triangle that I marked theta, we could find that with a tangent because 40 is opposite, 200 is adjacent. So I'm going to say theta is tangent inverse of opposite over adjacent. So it's going to be 11.3 degrees. And this one, I think it said round to the nearest 1/10 of a degree. So we're going to round that to 11.3 degrees. But 11.3 is not the angle that we're looking for. 11.3 is this tiny little angle theta. This theta is 11.3. What we're looking for is the angle that's labeled track. We're looking for the angle not 11.3, but 11.3 degrees less than the 75. So the track that we're looking for is going to be the whole 75 minus the 11.3. Take a 75 and subtract the 11.3. So 64 point negative 3, 60, 63.7. Thank you. So there's extra steps, because what we're looking for is not a piece of the triangle. One of our answers was a piece of the triangle. The other one was not a piece of the triangle. Good question. Whenever we're doing the subtracting, we don't really have to worry about the rounding that much. It's not going to be a problem. Because we're only giving it 10. Bad form on my part. I put a box around and not answer. How's everybody okay? Everybody looks stunned. You'll look like this. That's because it's like Tuesday afternoon and you're in a math class. That's in its second hour. I don't know how you people do this. It's ridiculous. Be like, Lee, you got a 3-hour class on Tuesday. I'm like, oh, okay. Well, it says it right here in the schedule. Yeah, I know it's what it says in the schedule. They're going to teach a 3-hour class, right? See, the way I get away with it is that the rate of information that I dispense is higher. So if I was going at a 1, then yeah, it's going to take 3 hours. But I did information at a speed of 2, hour and a half. By how fast you go. Okay. I think it's because I talk too much, though. You can slam through problems a lot faster, but the point, like you hired me to explain what the problems are about. So I have to explain the problems and say why I picked these particular problems. Okay. Any questions? How are we doing on the quizzes? Is anybody really mad at me because my ridiculous requirements that you have to be so precise? Anybody mad about that? Okay, I'm just going to make it more precise now. Because for things like when it said 65 point, it said something like 63.78. I actually was taking 63.7 and 63.8. I'm saying them both. because I was allowing you to truncate or round. That's a legacy because I used to say round or truncate to the nearest 10th. Truncate just means you stop writing. And then round means you either go back or go ahead. Then at some point I switched the wording to say round to the nearest 10th. I'm like, oh, that's right. I want to make sure they know how to round. And then the other half of me said, that means you have to go back and eliminate some answers. And I'm like, oh, yeah, but I'm not that. You're going to send them the wrong message. And they're going to be confused. Which is bad on my part. I know better. I train dogs, so you need to be precise in your communication. But I think I have to let this one go. Any questions? Comments? Or snide remarks? How's trigonometry doing? Is it okay? I don't know. It's hard to tell, like, if the rate is good or the rate is bad. Rate too slow, I don't really, that's not a thing. That's not a thing. It's like, I've already finished chapter 7. And it's like, put it for you. Congratulations. You can be done with the class, right? The problem is, if I'm like doing 80 problems a day, and you're like, oh, no, I'm about a 40 problem a day person. Then we need to make a judgment, right? Not all right. That's your only project currently. We have not talked about radians. Notice that chapter 3 is all about radians. I'm going to start talking about chapter 3 on Thursday. We're going to introduce radians. We kind of introduced radians a little bit already. We're actually going to start thinking more in terms of radians. As a preview, it's going to be that unit circle from your perspective, the unit circle. But instead of 0, 30, 45, 60, 90, we're going to be like all, instead of multiples of 30, it's going to be multiples pi over 6. Instead of multiples of 45, it's going to be multiples pi over 4. We're just going to do fractions instead of multiples of 50. That's it. And it's just an association that we're going to make in our mind. We're going to accept that the ancient Greeks were idiots when they're like, oh, pi is 3.14. So a full circle is 2 pi. You fuckers. What's wrong with you? I want to go back in time and find out what's going on. Why did you guys want to use the diameter? Look at the radius. That's how you make a circle. Why did you use it? And then I'm going to find out. And then I come back in time, come back into the future. I'm like, oh, wow. No, it makes sense. And then I'll be like, all fully on board. It's like, oh, nope, trig students just have to suffer. Full circle is 2 pi, half circle is 1 pi. Quarter circle is 1/4 of a pi. Or quarter circle is 1/8 of a pi. All right. That's going to do it for today. I will see you all on Thursday. Everybody have a good couple of days. And thanks for playing. And happy Valentine's Day.